Historically, we've used fossil fuels to generate heat and to generate cold. So for example, natural gas to heat our homes, natural gas to heat our food, natural gas in our industrial processes. We've used fossil fuel generated electricity to generate heat and to run our air conditioning processes. And now it's important to identify and implement low carbon sources of energy to generate heat and to generate cold. So low carbon heating and cooling has two main advantages. The first one is around the significant potential reduction in greenhouse gas emissions, and the second one is around social value. Global heating and cooling contribute an enormous amount to greenhouse gases. In fact, it's around about 40% of greenhouse gases are caused directly or indirectly through heating and cooling. So transitioning to low carbon sources of energy to generate heat and cold will therefore have a substantial impact on global greenhouse gas emissions. It's also part of a strong social mission. Billions of people in the tropics and the subtropics currently do not have access to air conditioning. For example, in India, around about 4% of the population have air conditioning, which contrasts to 90% in the USA. Adoption of air conditioning in these regions is going to be accelerated, so ensuring that increasing demand is met with minimum greenhouse gas emissions is vitally important. The energy crisis is also leading to more households facing fuel poverty. The first thing that needs to be done is to improve the thermal efficiency of the buildings, so insulating our buildings. But the adoption of photovoltaics, for example, and the adoption of more efficient heating technology will at least help to contribute, will help to reduce the impact on those households of this energy crisis. There are a couple of risks and disadvantages that need to be addressed through the adoption of low carbon technologies. One of them, for example, is the adoption of hydrogen. Green hydrogen specifically, requires typically electrolysis. Electrolysis is where you crack the water into hydrogen and oxygen. You need quite a lot of water to generate a kilogram of hydrogen. In fact, it's between 16 and 35 litres of water to generate 1 kilogram of hydrogen. And therefore, there is a potential impact on water resources that could affect clean water for sanitation. Desalination might be a solution to this, provided it's green desalination, i.e. it's powered using green energy sources. But desalination also poses some risks. Desalination has waste products, which is a hyperbrine, so a very high concentration of brine water. That needs to be disposed of very carefully back into the oceans to minimize risk of impacting the health of those oceans. Electrification of heat and hydrogen for heat also has a risk around affordability in two different ways. So hydrogen has got a higher levelized cost compared to natural gas at the moment. That needs to be addressed if it is to be adopted without impacting the end consumer. For electrification of heat through heat pumps, there's a very high cost of capital, so the investment required to install heat pumps is currently a great deal higher than your conventional natural gas boiler, particularly so if it is installed as a retrofit to an existing property. And so there are therefore both environmental risks that need to be considered, but also the social affordability challenges that need to be addressed. Governments and organisations play an important role in helping these new technologies to achieve their potential. One of the ways that they can do this is through facilitating, sponsoring, funding large-scale trials of these technologies. For example, we're seeing many examples where hydrogen for heating in domestic properties are being trialled around the world. Governments can also stimulate the development of the technologies, the acceleration of the technologies through grants. These grants can help to build the scale, to reduce the cost, to improve the simplicity of installation. Governments can also fund the insulation of properties. Insulation needs to be the first step before you start to introduce these more advanced technologies. Organisations and investors can also play an important role here. They can invest in their technology, they can develop their technology to respond to this growing market need. So we're seeing some really interesting and pioneering new technologies in this space now. For example, there's a new technology which combines photovoltaics with solar thermal. That technology enables you to produce electricity, or to generate hot water, or to desalinate water. And another really interesting application is the application of photovoltaics combined with highly insulated packaging and thermal storage to transport vaccines and medicines, to keep them at their safe temperature for extended periods of time during transport. This is particularly interesting in those developing countries where the infrastructure for power supply is limited. So low carbon heating and cooling plays a really important role in decarbonising energy and reducing global greenhouse gas emissions. We're seeing tremendous evolution and development of new technologies. We're seeing these technologies being adopted now at scale, and we can forecast that there's going to be a big impact on the lives of people and on our planet going forward.